John, we know that the PV industry wants to achieve grid parity, but maybe give me some insight into where materials play their part.
Well, so the roadmap to grid parity is absolutely enabled by materials. In DuPont, we focus our R&D, materials innovation efforts in three main areas. First is improving conversion efficiency. Second is improving the lifetime performance of the system. And third is reducing the overall system's cost. One great example, just a single example of how these innovations have impacted efficiencies and cost of PV electricity is in our Solamet metallization business. Innovations in this single product alone over the past 10 years have resulted in approximately 50% of the total improvements in the PV industry's cell efficiency gains. So materials are absolutely fundamentally important to our drive for grid parity.
Well, you mentioned that there, but you know, the conversion efficiency aspect, you know, that's obviously, you know, everyone's looking at conversion efficiency as a driver. Again, it's the materials playing that in the conversion efficiency side.
Conversion efficiency, as you know, gets a lot of attention in the industry. And the reason is because it's so fundamental to total PV cost. When you improve the conversion efficiency, you get benefits in terms of cost per watt in the cost of the module itself. You get that in the balance of systems cost, and you also get that improvement in cost per watt in the installation cost. So the leverage to improving conversion efficiency is incredible.
A lot of emphasis is you know, really put on the cell side, but surely, you know, more attention should be done on the module. Where can we get the performance gains out of the module? Well,
so one area that's often overlooked in module performance is in module packaging materials, and a key element of this is the backsheet material that you've heard me talk about before. So the economics of PV power depend on these systems operating efficiently in the field under very harsh outdoor environments for 25 years or more. And it's important that as we drive down this roadmap to grid parity, and we're innovating new materials and bringing new materials in, it's important that we maintain this long-term performance that the industry and that, more importantly, investors and owners of PV systems have come to expect. So backsheet and encapsulant materials, these materials are fundamental, and we're telling that story downstream. We're helping our module makers explain this story to their customers, but more importantly, we're working to help their customers downstream, owners, developers, lenders, to help them understand the importance of having good quality materials in these systems, and that we ensure that these systems last and produce power for 25 years.
A more sensitive and a more difficult question, and something that we're certainly hearing a lot from PV manufacturers is reducing costs. And there's got to be something there to me that says you reduce costs, you use inferior materials. I mean, what are the risks involved?
Well, maintaining the confidence of investors and system owners in PV power is fundamentally important to the long-term success of this industry. The testing that we do today of modules and materials, the UL and the IEC tests, these tests were never designed to predict long-term performance of systems. They're designed to assure safety and functionality of these systems at the time they're manufactured. So I'm an advocate of improving testing and standards that assure long-term performance. I'm also an advocate for content transparency in the industry. As an owner of a system, I would like to be able to understand the quality and the proven performance of the materials that are used in my system. And I would like to know that if I specify these quality materials, then I could be assured that they'll be used in my module, so I can be assured of good long-term performance and good investment returns.